Hello and good morning, everybody. Thank you for joining the webinar today. We'll give folks another minute or two to log in and we will get started shortly. Thanks for joining. All righty, let's go ahead and get started. Hi, everyone. Welcome to today's Better Buildings webinar, dedicated to bringing you the latest actionable insights from leading industry experts. These webinars are a chance to explore the topics, technologies, and trends that affect your organization, as well as efforts to accelerate energy efficiency strategies and reduce costs. Today's webinar is the 2025 Better Project, Better Practice Showcase. So we're going to be highlighting for you some of the award-winning projects and practices from some of our partners today. Before we dive in, there's just a couple of few housekeeping points that I'd like to cover. First off, today's webinar will be recorded and archived on the Better Building Solutions Center. So we'll follow up with today's recording and slides once we make them available. All of you are in listen only mode, so your microphones are muted. If you experience any audio or visual issues throughout the webinar, please do use the Q&A box to send a message to our tech support team. It should be in the bottom of your Zoom panel there, and our team will be in touch with you to try and help you troubleshoot. My name is John O'Neill, and I'll be your moderator today. I've worked in the DOE's Industrial Technologies Office for the last 4 years. I'm the program manager for the Better Plants program and the industrial sector lead for the Better Climate Challenge. I also manage our industrial technology validation program, which demonstrates the performance of innovative technologies in real-world industrial settings. I'm really excited to be here with you today to showcase some of the best examples of leadership across not just our industrial sector partners, but also Better Buildings partners across the hospitality, healthcare, and higher education sectors as well. So a wide variety today, and looking forward to sharing it with you. So really quickly, today's agenda, after all the introductions and overviews are out of the way, we'll do a quick welcome poll. We'll use a separate app for that, or a separate site for that called Slido. We'll fill you in with some more details on that in just a moment. Then we've got 7 different speakers for you today, and we'll finally close out with question and answer session, which will also be managed through that Slido poll app. Every year, DOE recognizes partners annually for outstanding accomplishments in implementing industrial, energy, water, and waste solutions in individual buildings and facilities, and promoting practices, principles, and procedures in energy management. In today's webinar, we have a selection of Better Buildings and Better Plants partners sharing the exciting, innovative, and impactful projects and practices from their organizations. So looking forward to sharing it with you. Okay, if everyone could take a moment and go to www.slido.com. That link just got dropped in the chat. You can enter the event code DOE. You can do this on your mobile device or on a separate tab on your browser. If you would like to ask any questions of our panelists, you'll use the Q&A function in this tab. So there'll be 2 tabs sort of at the top. One is Q&A and one is for polls. So at any time throughout the presentations, feel free to drop your questions in there. You also have the ability to thumbs up questions that you like, and that kind of helps us prioritize what questions we bring to the top at the end when we get to the question and answer session. So we'd like to learn a little bit more about you and your experience and who you represent. So we're going to start off with a poll. So please go ahead and again join us over at Slido and respond. We just have one quick poll for you about what sector you represent. We like to get a feel for who's in the room and who we're talking to. And again, if you have any issues, please message our tech support team using the Q&A function within Zoom. So it looks like we're starting to get answers trickling in. Great. A lot of industry representation. Love to see that. Very good. Some state, local government, nonprofits. Excellent. A nice mix today. All right, I think we're starting to level off here a little bit, so feel free to finish that off, and then once you've responded to that poll, go ahead and switch over to the Q&A session, or the Q&A section of that Slido page, so that you're ready to drop in questions for our presenters. Um, but we have a great lineup of presenters for you today. So first up, we'll have John Calamine, Senior Manager, Energy and Environmental Impact at Marriott International. That'll be followed by Chad Snodgrass, Process Engineering Lead for Sustainability at Sherwin-Williams. Then we've got Joe Barnes and Sam Shiroff. Joe is Engineering, Maintenance, and Facilities Manager at Enersys, and Sam is Senior Director of Global Sustainability at Enersys. After that, we'll have Patrick Burke, the Director of Engineering at Atlantic Health System, Dan Smith, an Energy Manager and Special Projects Coordinator at Bard College, and finally, Kyrene Mo, Senior Sustainability Engineer at PepsiCo. Thank you to all of our 7 speakers for being with us today. We're going to kick things off with John Calamine. John is a senior manager on the engineering and environmental impact team at Marriott International, where he's responsible for the organization's carbon accounting, sustainability data, and reporting. Specializing in Scope 3 emissions, John has led key initiatives in supply chain emissions modeling and programming AI to enhance analytics and automation. With that, I'll hand it over to John to kick us off.
Thanks, John. Hi, folks. Yes, my name is John Calamine. I work on the Energy and Environmental Impact team here at Marriott International, and I'm excited to present to you today on Marriott's Better Practice submission. This is an internal program we named Sustainability Scorecard. And in a moment here, I'll show the scorecard and highlight all the key details and processes for replicability in your organization. At the heart of it, Sustainability Scorecard has been an extremely successful endeavor for Marriott, not just from the benefits of streamlined reporting, but by catalyzing hotel action in a gamification setting. We ultimately found the right balance of metric reporting and action incentivization, such that we've been seeing an explosion in hotel efforts to make their properties more sustainable since scorecard rollout approximately 1.5 years ago. Next slide, please, John. So at its roots, Sustainability Scorecard is a Power BI report, and we engineered it from a variety of data feeds. But how did we get there? So a few things on that. First, the business identified and aligned on its core business needs. We already had done a lot of work in the space related to our science-based targets, greenhouse gas emissions reduction, and other ESG undertakings. And we simplified our success indicators and aligned on some key metrics. After that, we realized we need to respect the individualized paths of accountability at the regional and continental leadership levels, simply because when you have 9,000 hotels, 2,000 of which are managed, everyone managed by Marriott, everyone does things a little bit differently. And then from there, the trick was to incentivize hotel action and keep the pressure on for more results. So under the key leverage section on this slide, I'm going to stress the bullet point on highly competitive hotels. This is really what made Sustainability Scorecard stand out among our other programs. And a little bit on kind of the history on that. Serendipitously, Marriott stood up a different gamification program among its engineering discipline years prior. And we found a great surprise, a high level of competition. It was far beyond our expectations. Our first gamification program, which I'm happy to take questions on or one-on-one with anyone offline, this was just for points and recognition. There was no money or other prizes. But combining this with an app, to streamline engineering duties, our engineers were able to take on more with more enthusiasm. So we leveraged this culture of competition with Sustainability Scorecard. And combining this with some robust data engineering, hotels can see their full sustainability journey and future opportunity. And lastly, the core teams that put this together was the Marriott Sustainability team, my team, the Energy and Environmental Impact team, and our global procurement team. Next slide, please. So this is what the scorecard looks like. This is a sample from our Asia Pacific excluding China continent level. And it's similar in look at the property level. All the views at any level pretty much look the same. So we report on 6 key metrics, and these are all tied to our larger corporate sustainability strategy. We have sustainability certifications, energy use assessments, also known as energy audits or action plans, whether properties are meeting their energy reduction goals, sustainable procurement, water action plans, and reporting on waste data. The continent and regional roll-ups inform our leadership of opportunities and enable unique collaboration to boost metric performance in one or all areas. Next slide, please. This next view shows a property level view, and it reports on the same metrics as the prior slide, but with an additional one for utility data reporting. And that's that mesh compliance piece in the upper left area. And you can see the points breakdown by metric and points. They're awarded for each leg of the journey. So for example, we award a point for identifying a suitable sustainability certification, a point for applying for it, and a point for getting it. And similarly, we award points for planning, starting, and finishing energy and water conservation projects. So this is the roll-up for our properties. Next slide, please, John. So this is the best slide for us to talk about because it shows our impacts. And I'm excited to announce our progress in the sustainability space as a result of this scorecard. So we launched the scorecard about 1.5 years ago. These metrics, though, are as of April 2025, so they haven't been updated in the past few months. But looking at that April 2025 cutoff, since then, hotels have completed over 2,000 energy and water conservation projects globally, and they're reporting over $69 million in lifetime savings through decreased utility bills, lowered operational costs, decreased maintenance costs, and so on. And what this means is our engineers are working with their management and ownership groups to successfully undertake various projects, which are generally costing less than $10,000. We've saved about 97 gigawatt hours of electricity and 60 gigawatt hours of natural gas, and these figures continue to grow. And lastly, we have added 337 sustainability certifications to the Marriott portfolio, and we're ultimately extremely proud of these figures and optimistic for future growth. So that's my presentation. Thank you very much for having me and the opportunity to share Marriott's success. We are all guests on this planet, and we hope this story inspires you to create similar programs for a greener world. Thanks again.
Very good. Thanks so much, John. Next up, we'll hear from Chad Snodgrass. Chad is based in Cleveland, Ohio. He's originally from East Lansing, Michigan, but intuitively has a bachelor's in engineering from the University of Michigan. He has been working for the Sherwin-Williams Company for 10.5 years and is currently the global supply chain lead sustainability engineer. He has previously worked in multiple field and divisional engineering roles. Please welcome Chad Snodgrass.
Appreciate it. All right. So the better practice that I am presenting on here is called American Idol, and it's an initiative we have at Sherwin-Williams in our supply chain, in our internal fleet, which may be unique for some other of the listeners here. But if you have a supply chain, really third party or internal, I think this process, this way of thinking is still potentially impactful to what you're doing. So what we're targeting, right? We have 4 sustainability goals as a company with a 2030 target. They're all based on a 2019 baseline year. So of the 4 goals, 2 of them were impacted by this project, and that is to reduce absolute scope 1 and 2 greenhouse gas emissions by 30%, which that absolute word is really actually very important, because even if we're growing as a business, which we have to be 30% less than we were in 2019. Well, specifically, our internal fleet has grown considerably since 2019, and it's making these goals a little bit more challenging because of the growth of our internal fleet, which we consider a business advantage. Really, in the grand scheme of environment, whether it's our trucks or somebody else's trucks, it's probably not a huge difference, but it does matter in terms of obviously our scope 1 and 2 emissions. So this is an initiative, and we're looking for every way we can to reduce our emissions in our internal fleet and our distribution systems, and then also to increase operational energy efficiency by 20%. The fuel usage rolls up into our bottom line, finished goods produced and sold versus energy used. So that's what this is looking for. Next slide. So just to give some background on Sherwin-Williams, us probably as a paint company more than anything, but we also have pretty significant industrial footprint as well. And we have over 80 sites, roughly 80 sites in North America that we consider our main global supply chain. So manufacturing and distribution sites are our big manufacturing locations. Then we have roughly 70 internationally across Latin America, Europe, and APAC. So we are spread out really in our business. We want to make our product as close to our customers as possible, and reduce the amount of shipping we have to do with our finished goods. So you can see all the different manufacturing locations, and then think about how we try and distribute to our customers all over the world. And another note here, I should add, we have 5,000, more than 5,000 stores, Sherwin-Williams stores globally, and 3,900 of those from the United States. So we're distributing to those stores as well as some of our distributors like Lowe's. Next slide. So we call our CTS is our internal fleet here. We have over 1,000 tractors, 1,057, and 945 Sherwin-Williams company drivers. This internal fleet represents about 20% of our scope 1 and 2 greenhouse gas emissions, so it is significant. And it's challenging for CTS to utilize alternative fuels in 2025 due to the heavy weight of our trailers. We're packing our trailers full with pretty much, gallons, pails, totes, drums of finished good paint. So they're very heavy trailers, which makes it difficult at the moment to utilize like an electrical tractor or something like that, an alternative fuel, to cut down on our usage. So really what we're focusing on right now, while we look at piloting alternatives, is being as efficient as possible in our current processes. And that's really what this project's built on. And in 2023, you can see we drove over 82 million miles and consumed over 11 million gallons of diesel fuel, which is the equivalent of 114 metric tons of CO2 emissions. Next slide. So this competition that we're here to talk about, the better practice, is called the American Idle competition. And it's based on trying to get our drivers to long idle less. Long idling is when they're parking their truck for some reason, maybe to cook food or to get some rest during their journey, and they're idling their engine, although they're not driving anywhere. And it's very wasteful. So this is what we were trying to reduce, and thinking of an initiative to how we would do that in the process. So it was a monthly truck driver competition intended to encourage drivers to use APUs instead of truck engines when idling. The top 5 drivers every month receive a prize for the lowest long idle time percentages. And these are distribution based. So our drivers are stationed or headquartered at a certain distribution warehouse across the country. So they're driving similar routes to their competitors for the competition. And so an APU is an auxiliary power unit. It's pretty much a smaller engine stored below the truck that consumes 75% less fuel than a truck engine when idling, while allowing them to cool their truck, or to make their food or whatever they need to do for a period of time. And I highlight in that red box, then you can see it up close, where it sits in the tractor. Where it sits, again, is pretty much just a generator that's more efficient than using the full engine, right? That's running all of the parts of the tractor that drive, and ignoring that to consume far less uh, diesel gas over time. And so we also implemented measuring systems to record truck efficiency, performance, and idle time data, and added periodic maintenance checks to verify that these APUs were operating efficiently. Before, we were having drivers use excuses that their APUs weren't working, and it was kind of on them to go get them fixed. Instead, we made it periodic to where we're ensuring these are working, and it can't be an excuse for drivers not to use them. Next slide. So our outcome from this initiative, you can see in 2023 versus 2024, our miles per gallon went from 7.42 to 7.64. This takes into account long idle time. And then our long idle time percentages dropped from 10.6 down to 8.7. So we still have a ways to go, but it made a significant impact. And the diesel gallons consumed was reduced by over 500,000 total. And we attributed 308,000 to this initiative, which is the equivalent, again, of 3,144 metric tons of CO2 reduced in our Scope 1 emissions, and over $1 million in annual fuel savings. So very impactful, and a very simple concept. And we're going to continue to look for everything we can in our distribution systems to be as efficient as possible. That's it. Thank you.
Thank you, Chad. In addition to a Better Practice Award, this also won our first Better Pun Award for the title of the American Idol competition. So
appreciate it. Yep.
Next up, we'll hear from Sam Sheeroff and Joe Barnes. They'll co-present. Sam is the Senior Director of Global Sustainability for EnerSys, the industrial technology leader serving the global community with mission-critical stored energy solutions that meet the growing need for energy efficiency, reliability, and sustainability. Joe has been at EnerSys for 17 years and currently serves as the Engineering, Maintenance, and Facilities Manager at the Warrensburg, Missouri TPPL battery manufacturing plant. Aside from daily operational support, Joe is responsible for all capital project management and budgets, with a focus on safety improvements, automation, cost savings, and scrap reduction. Take it away, Joe and Sam.
All right. Well, thanks, John. Yeah, we actually won 2 awards, so I'm gonna go first. To the shorthand of what John just described EnerSys as is, we make industrial batteries and provide services along with them. The nice thing about being the head of sustainability at an industrial battery manufacturer is that our products themselves are, in large part, our main contribution. They really help our customers around the world reduce their energy costs, fulfill all of the services they need using electric batteries, and can also reduce their climate impact at the same time. We're in a broad range of areas, say from submarines to satellites, and a lot of stuff in between. So whether it's a forklift truck or uninterrupted power supply for a data center, that's where EnerSys is as a company. And certainly, while our products do provide this potentially significant impact, of course, we want to walk the walk if we're going to talk the talk. And part of developing a sophisticated and professional sustainability program are setting climate goals, but goals aren't enough. You need to determine how it is that you're going to actually execute on those goals. And to that end, we have developed a pretty detailed climate action plan roadmap. And what you're seeing here, and you'll see on the subsequent slide, will be the infographic that gives you a shorthand for the 70 pages that it otherwise is. You can see on the right-hand side, our current footprint and where we need to get to fulfill our 2040 Scope 1 goal and 2040 Scope 2 goal. And our focus on electrification as a key to decarbonization. Next slide, please. So we won the award for our green revolving fund. which you can see here at the upper left-hand kind of quadrant. For anybody on this call who's ever gone and had the conversation about how a macro transition is going to look, and the very large sum of money that it might ultimately take to get from one place to the next over a 20 or 30-year period, it's easy to take that in increments. And basically, the way the revolving fund works is we seeded it with approximately $20 million to be spent over a 5-year period. We are looking for the lowest hanging fruit, projects that have a high ROI and a high climate impact, and we invest in those. And the return on that investment flows back into the fund so that by 2028, with approximately 20 million, is quote unquote invested in our own projects, not only have we reduced our fund, but we've reseeded the revolving fund. And this enables us over time to ultimately get to the point that we need to adequately reach our 2040 and then subsequently our 2050 goals. We manage this internally, and it really has been an exciting, almost competitive activity amongst our various different factories. And we have some really fantastic projects that are examples. And as I'm going to kick it over to my colleague, who also will talk about one of the very first projects, and just how exciting that has been for us, and the impact. So, Joe, I'll hand it over to you for the next.
Great. Thank you, Sam. And it's my understanding we were the first project, actually, to be awarded capital money for this green fund. Hello, everybody. My name is Joseph Barnes. I'm the engineering manager here in our Warrensburg facility. This facility, a little history on us, started in the early 80s with our Plant 1. We built the bulk of what we use today in 1995, what we call Plant 2. We expanded that again in 2008, 2009 timeframe, and then again to the south in 2011, 2012. So we have here a multi-generational building, and those systems are not integrated into one thing. Building 1 has its own infrastructure. Building 2 has its, the east expansion has its, the south expansion has its. So what we wanted to do, and we've always known this kind of inherent inefficiency in our system, what we wanted to do was bring that all into one central platform. We knew that we had systems competing against each other, and we needed them to talk to each other. So we worked on this for many years. When Sam and our corporate office had this Green Fund initiative, we realized this was a perfect fit for that. It was what we were already working towards on it. So reduce CO2 emissions, reduce utility costs, and then from our internal perspective, increase our reliability and our uptime of our aging utilities. So next slide. So we did this by partnering with Train Systems. Train's tracer synchrony system is the integrator that we landed on to help us with this. And what we had to do was network all of these devices together. So we started obviously with an audit of all of it, and found 107 devices that were completely standalone, either had no information or was simply an analog gauge, manual recorded information. Those got all brand new control devices for them. In Plant 1, our oldest system, there were 61 devices that went all the way back to paper reel graph recorders and logs like that we had to keep. We had 61 items that were an upgrade. Plant 2 was a bit newer. Those systems were simply older, so we had to get those to the modern generation of control devices so everything talked together. Then along with that, we also have multiple inputs into our facility of our utilities. So our gas comes in multiple places, our electric comes in multiple places. We wanted to tie all of that utility monitoring so we could actually get not an estimate, but an actual real world number of how much gas we were using, how much electricity we're using, and which general area of the plant are we using it in. We also had some EPA regulations that we have to adhere to with keeping a negative pressure on our building. So in case we have a lead leak internally, it doesn't get out of the environment. Some things like that that we integrated into this system as well. All of that comes into one centralized web-based platform, and that platform is really the heart of this system. So next slide. So this is a snapshot and a little bit of a walkthrough of the Train synchrony tracer system. It's a very visual based system. So you get the platform and then you build in a model essentially of your building. So you'll see in the upper left area there, that's a basic outline of our building. And you can see it's all P1, P2, East expansion. Everything is labeled by general area. From that, you click on each box, you go to an area that gets you a further layout that we dropped in further from there. And then on top of that, you get down to your actual devices. And the really good part of the system is you can pull that device up, you can input all of your settings, all of your alarms, all of your data logging, you can tie units together. You can monitor everything, you can change everything, and you can get a snapshot from one portal location, either a desktop or a mobile location, it depends on what access you have, and you get instant results at any time of what your system is doing. So next slide. So obviously we didn't do anything with our main HVAC systems. We knew that they were pretty good shape. We do a good job of maintaining our actual refrigeration units and our chillers and our coils and everything like that. So we knew the increased efficiency was going to come from the communication level of those. And that's when it actually exceeded our expectations. You have systems that were cycling 25 times a day. And if you know anything about refrigeration systems, they want to run at a steady state. You don't want to be having to turn them on, turn them on, turn them off. We reduced some of those systems down to 3 to 5 cycles per day. And that really is where our utility savings came from. So we ended up with a annual utility savings of close to $250,000 last year. Evergy, our local utility company, had an incentivized bonus on that of another 300,000, and that equated to almost 2,000 metric tons of CO2 reduction. Along with that, that's the environmental side of it, that's the sustainability side of it. What really helped us on our internal side was I can send my guys out with information in hand when there's an issue. If they have to go outside, go on the roof, they can go to the portal first, know what equipment to go to, what's actually happening, what's doing wrong, and sometimes troubleshoot it from the comfort of their office and make an adjustment. Those are invaluable when I see those things, and it saves me half a day worth of getting to a work order. So last slide. So a lot of the challenge we faced obviously was the distance. This is a 14-acre campus. A lot of networking and cabling and everything had to be run and hubbed up. But once we got that, and then each generation talking to each other, getting the outdated generations up to the new generations, really just came down to loading in. I mean, it's a very powerful platform, but loading in all of your set points. And some of these are set points that we had never had before. We had 107 new devices, and we had to go through and design high and low settings, preferred parameters, alarm settings, high alarms, where do we kick the alarms out to? And we're still working through that now, and the system continues to naturally mature as we gather data. So it is a continuing growing process for us. And that's our system.
Great. Thank you, Joe, and thank you, Sam, for sharing. I'll remind the audience briefly to go ahead and send any questions you have for our presenters. Send those in at www.slido.com. That link should be in the chat. The event code is DOE, so please use that platform for submitting questions if you have any. We will go through a question and answer session at the very end of all of our presentations. Next up, we'll hear from Patrick Burke. Patrick is the Director of Engineering at Morristown Medical Center. He has 35 years of industrial experience managing utilities, maintenance, and operations of a 1.5 million square foot power plant at a regional trauma center. Patrick, go ahead.
Good morning, everyone, and thank you for the opportunity to tell this story. You can go to the next slide. The Morristown Medical Center's CHP plant was a project that was in the works for well over 10 years, and it wasn't that we were designing, but initially when it was proposed and talked about, you had everything from comments, it won't work here, and essentially it wasn't going to solve all the problems that we had. So during that time period, the project grew, and it grew to include all of the electrical infrastructure on our campus. And what that involved was taking over all the primary voltage equipment from the utility company and purchasing it and replacing it on the campus itself. During that process, we maintained two individual primary voltage feeds. One of them is active all the time, and the other one is on standby. That puts us in a position where we are less reliant on our emergency generators, and that's critical at a hospital because even though emergency power backs you up, there are certain functions like surgeries that you won't start when the hospital is on emergency power. So having a second utility feed that you can automatically switch to is really a nice luxury in terms of resilience and reliability. The plant itself is a 4,600 kVA natural gas turbine. It generates approximately 70% of the electricity that we use each year, and it produces exhaust gas that's about 700 degrees, and that exhaust gas is used to make steam for the facility for both heating, hot water, and sterilization in sterile processing. Also, as a note, we upgraded our utilities in 2024 as well by installing 1,500 kVA worth of solar panels. Next slide. Okay. So how did it all work? In 2024, the turbine was up over 99% of the time. We produced 70% of the campus demand. The original projections were 65%, so we've been running well, and we've exceeded those original targets. The Herzig produced 52% of our total steam demand. The goal was 45, so that's huge because that saves us money as well, and that puts the plant, a CHP plant, in kind of a sweet spot in terms of maximizing your return on investment, being able to use that hot air and make steam, and to be able to use all of the steam that you can produce. The solar panels produced a modest 4% of electricity over the course of the year. We'll probably hit 5% this year because we're going to pick up a few extra months. So even though that's not a big impact, the real savings there is that on hot summer days, and I say this a lot, on hot summer days when it's sunny out, you're getting your maximum production from your solar panels. And what that does is it reduces your load on the utility. So even though over the course of a year, you are only generating 4% of your electric, a lot of that is coming in the middle of the day. And on those hot summer months, when there's a tremendous demand on the grid, we're lowering it significantly on those days. So there is more than just a financial benefit from the solar panels. It's almost you're being a good steward to the utility company. Overall, the turbine alone saved $3.8 million in electrical costs. By converting the hot exhaust gas to steam, we saved an additional $500,000. and the solar energy came in with a savings of about 123,000. And again, that I temper that by saying you get that on those hot summer days in the middle of the day. So that's a good thing that doesn't really show up in the cost savings. So our total utility savings in 2024 was over $4.4 million for the year. Next slide. Okay. And then we get to the environmental impact. And again, the removing 2,600 cars off the road, that's over a 10-year period, the lifespan of the project, even though we expect the turbine to run much longer than that. It actually gets, the engine gets replaced every 5 years or so. And it's hard to believe, but we're coming up on 5 years in a few months. And we're almost looking at that first major rebuild, if you will, or replacement of the engine. But it's running extremely well. There's a part of me that doesn't even want to touch it, but that's all in the plan. Next slide. I like to include these pictures because realistically, what makes this all work is the team. And that is the individuals that are monitoring this equipment, that are running it, the preventive maintenance work that we do. We shut the turbine down twice a year for about 4 days, and we go through a whole series of checks on it, adjustments. There are some mechanical parts that get replaced and things like filters. There's HEPA filters on this. The filters alone cost, I think it's like $14,000 a year for the HEPA filters, which is like the air filter on your car. It's just a lot bigger and there's more of them. There's a lot of technology, there's a lot of computer monitoring equipment involved, and the system has been very successful for us. Since it's gone in, we have not had a power failure, utility failure that has required us to go on emergency generators, other than a couple of blips that we've had, in situations where we just had to go and throw a switch, and within a matter of minutes, we're 100% back on utility. So it's been a very successful project for the hospital, and we're actually doing more at some of our sister hospitals as well. So again, I'll wait until the end of the meeting to answer any questions, but thank you for the opportunity.
Thank you for sharing, Patrick. Next up, we have Dan Smith. Dan is the energy manager at Bard College, located in the New York Mid-Hudson Valley. He has overseen a variety of energy-saving capital projects, including geothermal systems, campus-wide lighting retrofits, HVAC and controls upgrades, building envelope improvements, goat mowing, and solar installations. He manages the college's energy procurement, participation and demand response, greenhouse gas inventory, and climate action plan. Take it away, Dan.
Yes, good morning. Thank you for the intro, John, and thanks everyone for having me. We can proceed to the first slide. So welcome to Bard College. We are in the Mid-Hudson Valley, New York. We're nestled against the Hudson River, and those are as you can see by this lovely artist rendering, we're the Catskill Mountains in the background, and it actually does look like this. So just a brief history of geothermal at Bard College. Nearly 50% of our main campus building area utilizes geothermal for heating and cooling. We were an early adopter of heat pumps and geothermal dating back to the late 1980s. It's the default for all of our new construction, and there are over 630 geothermal wells peppered about campus hidden beneath our feet. Next slide. So the project we're presenting today is the conversion of our existing library facility. You can see both these pictures. The one on the right is we're in mid-drilling. We can proceed. So there's a bit about the project, the library. This was our first conversion of an existing building. So we have a lot of geothermal on campus, but those were all new construction at their time of completion. So this is the first conversion of an existing building from fossil fuels to geothermal. It's a roughly 60,000 square foot building composed of three vintages, 1890, 1978, and 1992. The geothermal well field consists of 50 boreholes, each 500 feet deep. We replaced a 160-ton heat pump plant, so that gives us N+1 redundancy. If ever we lose one heat pump, we're still good. With the project also included a pretty considerable mechanical overhaul. So a new ERV, energy recovery ventilation system, to help bring the building up to code, ventilation-wise, a new building automation system, and the replacement of 90+ fan coil units and small air handlers. So this really was a open heart surgery, open lung surgery, open nervous system surgery, and we did it all while keeping the patient alive and moving and occupied. So some of the challenges were adapting within the old infrastructure, maintaining occupancy and programming, and we did do a little bit of education and outreach. We just brought the community along with us through this project, dismissing or re-educating that it was not fracking that we were doing. We weren't doing mineral exploration on campus. Next slide. We have a treat for you. We did a time-lapse video of the drilling, so we can push play. And we have some inspirational music playing, and I'll narrate a little bit as we go. So the drilling took place from approximately 3 to 4 months, from January to April. And the field itself is our commencement field. This is adjacent to the library and our dining facilities. So it's also our commencement. So we were under a rush. That was one of the challenges we took on, was to get this completed before our commencement ceremony. You can see up to 3 drill rigs going at once. That was one of the challenges, was a very condensed drilling and field construction schedule. You can see in the back of the field, that's our water spoils filtration system. So we were taking in water spoils, and on the outflow was perfectly clean water that we put into our sewer system. Here you can see the laterals being put in and the lateral piping. So we're joining all the boreholes together into a grid. And here's our commencement floor going down. So we finished our drilling, regraded the field. There's the commencement tent going up, and that's sort of the end of our process from start to finish. So we can push pause on this to the next slide. And wrapping up, here's the impacts from the project. Just a great, real meat and potatoes project. We eliminated the burning of 14,000 gallons of fuel oil per year forever. We reduced the site carbon emissions by 127 tons CO2 per year. We reduced the site energy use by 38% and the site emissions by 64%. And we also laid the groundwork for our future conversions on campus, namely our financial partners, our mechanical partners, drilling partners, and we're already working on the next 2 to 3 conversions of our existing building stock to convert them to geothermal and push from 50% of our campus to geothermal. That'll take us to 80% and then hopefully 100%. And I believe that's the end of our show. Thank you, everyone. And I'll look for any questions in the feed. Thanks.
Awesome. Thank you, Dan. Now we're on to our final speaker of the day, Kyrene Moe. Kyrene is a sustainability-focused engineer with over 5 years of experience with Frito-Lay Incorporated North America, a PepsiCo company. Dedicated to enhancing sustainability in the supply chain sector, Kyrene has led numerous water efficiency projects in manufacturing. Please welcome Kyrene Moe.
Hey, good morning, everyone. Thanks for the introduction. So to kick things off, let me just introduce PepsiCo. So PepsiCo, we are a global food and beverage manufacturer. We make a lot of your favorite snacks and drinks. So products like Gatorade, Pepsi, Mountain Dew, Lay's, Cheetos. You probably recognize a lot of these brands. And there's water involved in that process. So water stewardship is one of PepsiCo's top priorities. And it's our vision that wherever in the world we operate, water resources will be in a better state because of our presence. So through the implementation of water efficiency best practices, like the one I'm going to share today, we're striving to improve our water use efficiency across our value chain and contribute to that vision. So moving on, what exactly is this project? I have a couple of animations here. If you want to just click through them. Yeah, that's good. Thank you. So this project is all about water spray nozzles. So water spray nozzles are an extremely common piece of equipment in the industry. I'm sure everyone here can think of at least one example in your facilities where you might use spray nozzles. So maybe you're applying water as part of your manufacturing process, or you're using it in a handheld spray gun, maybe to wash down a surface. But in food and beverage, especially, you'll find quite a lot of spray nozzles. And depending on the size of the facility, there can be hundreds to thousands of nozzles within a plant. And each of these nozzles is using water, maybe just a little bit, maybe 1 gallon per minute or less. But when you add them all up, we found that in our operations, more than half of a plant's total water consumption can pass through a spray nozzle. So it's such a tiny piece of equipment, but it has a really large part to play. And what we have to pay attention to with these nozzles is that each type of nozzle is sized and shaped just right to produce a desired spray pattern at a certain pressure and at a certain flow that's optimized for each specific application. And what happens over time is as these nozzles run constantly, they get worn down by minerals in the water or other external factors, and they get worn out. The orifice that controls the flow inside the spray nozzle starts to get bigger and bigger. And as that happens, the nozzle starts to use more and more water. So the more worn out a nozzle is too, the worse your performance gets with time. So how do we prevent this? How do we prevent wear and tear on spray nozzles? And how do we keep our water usage at a minimum? Next slide, please. So the answer is a preventative maintenance program. So for those who are unfamiliar, preventative maintenance programs in the manufacturing space are a series of regularly scheduled maintenance to prevent equipment breakdown. So same concept as taking your car in every year to get checked. The idea is you want to stay ahead of any big problems by doing routine maintenance. So in order to address our desire to develop a spray nozzle preventative maintenance program, we partnered with Spraying Systems, who's a global manufacturer of spray equipment, to put together this program. It was the first of its kind. We piloted the program with them, but it's now a service that they offer under the name Spray Easy. So if you're interested in implementing this program with them, you can reach out to Spraying Systems, or you can also perform it in-house. So let me take you through the steps of the program here. The first step is a scoping audit. So the first step is to assess what you have. You'll fill out a survey that asks how big is your site, how much water do you use, maybe provide some utility bills, how many production lines you have, what's your cost of water, basic information about your operations and your water consumption. And then Spraying Systems comes on site to assess the current condition of your spray nozzles and take performance data. So they'll look at pressure, look at flow, they'll look at every single nozzle in the facility and compare it to the baseline performance of that nozzle type. And what that does is you're able to quantify the size of your opportunity. They'll capture potential water reduction opportunities in your spray nozzles, and they'll provide actionable solutions in a report. The second step is to model that data in order to build a program that's optimized for both cost and performance. So the key here with PM programs, preventative maintenance programs, is that you need to know how often to do maintenance. So if you do it too often, then you're spending more money than you need to spend. But if you don't do it enough, you're suffering performance losses by waiting too long. So this is where all the data gathered from the first step comes into play. With this performance data, you can put together a model that shows exactly what the optimal replacement frequency is. So the longer you wait to replace, the more water you're going to use and the higher your cost, but also the longer you wait to replace, the lower the annual cost of each replacement is. So the model analyzes that data and it looks for the intersection of those two trends based on your specific operational data. And that will be the replacement frequency that works best for you. So the final step is implementation, which is putting the program into action. So you'll do your first replacement, you'll order the nozzles, you'll schedule the replacement, after which you should see an almost immediate improvement in your nozzle water usage. And then you don't have to do anything until your next replacement cycle. Then you replace the nozzles again and so on your replacement cycle for as long as you want to continue the program. And every time you replace your nozzles, you're essentially resetting and you're bringing your performance back to baseline. So it's a really straightforward concept, very simple, yet highly replicable and highly impactful. Next slide, please. So what kind of results has PepsiCo seen from implementing this program so far? We've implemented at 7 manufacturing facilities with extremely positive results all around. We had immediate water reductions, on average about an 8% water reduction compared to immediately prior to the installation, which translated to about 136 million gallons a year in water savings when compared to the prior performance at those 7 sites. So like I said, massive impact at a relatively low cost. This is a highly cost-efficient program for us. What that correlates to in productivity is about $500,000 in utility cost savings per year compared to prior cost pre-install. There's a couple other benefits too I'd like to highlight of this program. It's not just the water savings, it's not just the utility savings generated. It also is a systematic approach to equipment maintenance for us, which helps to ensure more consistent performance overall in both process applications and sanitation. And we're supporting sanitation in several ways too. We're using less water, but we're getting a better clean. We're getting a quicker clean, saves time, potentially reduces the amount of cleaning agents required as well, and it also supports food safety. So once again, simple, highly impactful, highly cost effective. For PepsiCo, this program has been a huge win in water efficiency, and we're extremely honored to be selected by the DOE to share this program with you all. So hopefully you feel inspired to do this at your own locations and carry this best practice across the industry. Thank you.
Wonderful. Thanks, Kyrene. And thank you to all of our speakers. We don't have a ton of time left, so we'll just try and get a couple of questions in here, and then maybe our panelists can respond directly in the Slido with some typed responses if we don't get to some of these. So first, I'm going to kick one over to Sam. For EnerSys, how exactly does savings from an implemented project go back to fund the revolving fund?
Turn my video on. Yeah, basically we obviously you don't have the exact numbers on every single thing because there's a variance, but we make an estimate on an annual basis. Obviously we know what our energy or water or other costs are. And with the estimate, we just do it in an accounting, right? There's a separate account that it's not like money flows in there or whatever. We just have done that on our books internally that we just keep track and then assign it.
Excellent. A question.
Joe looks like he wants to say something, but he's on mute.
I'll piggyback slightly on that. I recall Sam's team coming back and doing an audit with some information on that to make sure that our actual return was what we estimated to be, as best as we could calculate numbers. So they come back into the plant and did a walkthrough audit on what our actual return was going to be on that.
Very good. A question for Kyrene. Does nozzle preventative maintenance change pump energy use, and are you accounting for that in sort of your calculation about frequency?
Yeah, so we are not accounting for it, but there are some energy savings if you have a lot of, for example, heated water applications. So if you're being more efficient about your water usage, essentially not using as much, then you don't have to heat as much water. That could be something, as well as pump energy, the amount of water that you're pumping and the pressure that you're having to pump at to maintain performance through these nozzles that are being worn out versus if you replace them and keep them new.
All right, and maybe our final question, let's pop it to Chad. Chad, can you say anything about the installation costs of the APUs relative to the fuel savings and the break-even point?
Sure. Yeah, we get those APUs put in when we buy the trucks, but those cost, I think, on the market roughly $4,000 to $5,000, and the return on investment on average is a little over a year. So just from buying them new. The project we were talking about, we already had them. We just weren't maximizing their use.
Great, thanks. Well, to keep us on time, I think we're going to have to close Q&A there, unfortunately, but I will ask our panelists to go ahead and just respond with some typed answers to those questions, and our attendees can go ahead and review those at their leisure. But thank you so much again to all of our speakers, and thanks to those of you in the audience that provided questions. This webinar is part of a series. We'll be doing these all summer. Our next one that is coming up is called Beyond Curb Appeal, Exterior Upgrades that Drive Efficiency and Savings. So this will be all about exterior building enhancements and to drive energy savings and boost building efficiency. With that, I'd like to again thank all of our panelists very, very much for taking the time to be with us today. Feel free to contact them directly with additional questions if we didn't get to your question today. You will receive a notice when today's recording and slides and transcript are available on the Better Building Solutions Center. So if there's anything that you want to go back to and reference later, you'll have the ability to do that. But thank you everyone for attending, and have a great rest of your day.
Appreciate it.
Thank you.